Hi friends, myself Rahul Kotkar. Today we are going to discuss the chapter Rotational Dynamics from Standard 12th. Okay, this is our second lecture. In first lecture we discuss about the introduction of rotational dynamics. In this lecture we start with the point distinguish between the uniform circular motion and non-uniform circular motion. Okay, so here we are going to discuss differentiation or we have to discuss the difference between the uniform circular motion and non-uniform circular motion. Okay, so first we start with the definition of uniform circular motion. So what is the uniform circular motion? Simply, uniform circular motion is defined as the motion of the particle along the circumference of circle in which the linear speed remains constant. Remember, motion of the particle along the circumference of circle with constant linear speed is called as uniform circular motion. Okay, so first I am going to explain all the things related to the uniform circular motion. Okay, so friends, here second point that you can write the magnitude of velocity that is also constant. In simple manner, magnitude of velocity means what? That is the speed. Okay, so keep in mind the magnitude of velocity, that is the speed, is also remains constant. Okay, then next one is your velocity, that is the linear velocity of the body is not remains constant. Okay, linear velocity of the body is not remains constant. Okay, because the definition of uniform circular motion is what? The motion of the particle along the circumference of circle with constant linear speed. Okay, in which the speed remains constant. Okay, and so the velocity can be varying according to the simple thing. Okay, as previously we discussed here, the velocity is the vector quantity. This velocity is characterized by two ways. One is called magnitude and other is called direction. So the magnitude of velocity remains constant, that is the speed, but the direction is continuously changing, and so what we can say, the velocity of the body is always remains constant. So friends, next is your kinetic energy. So in case of kinetic energy of the body, what we can say, the kinetic energy of the body in which the one formula is there, 1 by 2 m into v square. So as we consider here, this is the magnitude of velocity, so then we say that this is the constant quantity. The kinetic energy of the body in a uniform circular motion is always remains constant. Okay, so next point is your omega, that is the angular velocity of the body. What about the angular velocity? So this angular velocity is also remains constant. Okay, because as you observe in case, okay, as we discussed previously, when a particle performing uniform circular motion, okay, this is the position of the particle which indicated by position vector. This is the tangent drawn to the circle and or circular path, and here this velocity remains constant, that is called tangential velocity, because it is along the tangent to the circular path. Okay, so what we can say here, the tangential velocity Vt as well as radius of the circular path, both are the constant things, and as both are the constant, so what we can say, the omega, which is having formula v divided by r, and so what we can say, that velocity which is called angular velocity remains constant. Okay, so next point is your tangential acceleration is equals to 0. So friends, why the tangential acceleration is 0? So the reason behind that, it's also simple, as the tangential acceleration is 0 because when a particle performing uniform circular motion, this is your velocity along the tangent, that is tangential velocity. If the tangential velocity is constant, then simply what we can say, as you look the formula of acceleration, so acceleration is the rate of change of velocity, okay, rate of change of velocity, that is dv divided by dt. So it is a rate of change of velocity, and this rate of change of velocity, if the derivative of constant quantity, as you take the derivative of this quantity, the velocity is constant, sorry, tangential speed, that is vt, is remains constant, and so what we can say, this derivative of constant quantity is always equals to 0. Okay, same thing we can apply for alpha is equals to 0. Okay, what is the alpha? Alpha is the angular acceleration. Okay, and this angular acceleration is defined as a rate of change of angular velocity. So as a rate of change of angular velocity is also remains constant, sorry, 0, means what? Tangential acceleration. What I am saying here, listen carefully. Okay, as alpha is equals to 0, alpha is defined as rate of change of linear angular velocity. Okay, and so as omega is constant, so what we can say, the derivative of constant quantity is always equals to 0, and that's why angular acceleration alpha is 0. Then next, what about the centripetal acceleration? Okay, what is the centripetal acceleration here? Suppose this is the particle, this is your position vector. Okay, so the acceleration of the particle which is directed towards the center, remember this direction I am indicating here, this is called centripetal acceleration. Okay, and this centripetal acceleration is never equals to 0, it have a certain value. Okay, the magnitude of this acceleration is remains constant, but what happens here, its direction is continuously going to be changing. Okay, means what, as you observe the magnitude is remains constant, but the direction of centripetal acceleration is continuously changing from point to point. Okay, so next point that I am going to discuss, the resultant acceleration, that is known as a net acceleration also. Okay, so what about this net acceleration? In case of net acceleration, okay, what we can say, how this net acceleration is obtained, that we know simply by taking a resultant of, okay, so this is an acceleration which is called net acceleration, and this net acceleration is the combination of this centripetal acceleration, this is your tangential acceleration, as we consider that this is a circular path. Okay, so friends, here by a simple formula, okay, as you substitute all these values, both are perpendiculars to each other, so according to the formula of resultant, everyone know the formula of resultant from scalars and vectors. Okay, so that is r is equals to under root of p square plus q square plus 2 times p q cos theta. So here cos 90 has value 0, and so what we can write, only a net is equals to under root of a square plus at square. But what is the condition here? This at is equals to 0, value of at, tangential acceleration is 0, as we discussed before. Okay, just so here a net is equals to ac. Okay, means the value of net acceleration is only due to the centripetal acceleration. Okay, then next is your work done. Okay, in case of uniform circular motion, work done by the force, okay, is always equals to 0. why the work done by the force is always equals to 0. So let's take an example. Here we consider that, okay, so here we consider the two forces again, as the accelerations are there. This is your centripetal acceleration, this is your tangential acceleration. So friends, in case of tangential acceleration, okay, so for everyone know the Newton's second law, and according to that, as the acceleration is produced in the body, so there is the force is present, means without force no acceleration is there, means as at is along this direction, so what we can say, ft is along the same direction. Also ac is present towards the center, and so what we can say here, the force is present which is called centripetal force. Okay, so remember friends, we consider the two forces here, one is called centripetal force and other is called tangential force. Okay, so while calculating the work done by the force, okay, in case of work done by the force is defined as, according to the formula, W is equals to F into S, means F dot S. Okay, but here we consider the centripetal force, okay, as the centripetal force multiplied by displacement, and again as you observe, this is a circular path, this is the centripetal force, this is the displacement, and both are 90 degree to each other, and so cos 90 has value 0, and so your work done by the force in the uniform circular motion is also 0. Same thing that we can say for a power. Okay, now in case of here, so in case of power is equals to work divided by time, it's simple formula. As we seen, work done is 0, so whole quantity becomes 0, means what, power is equals to 0. Okay, so friends, again another way to get this power equals to 0 is what, as you take a P is equals to force multiplied by displacement. Okay, as per the formula, that is work divided by time. Work is what, force into displacement divided by time, so displacement by time is what, velocity, and so again as you take a scalar product of these two quantities, that we have again cos 90, and as cos 90 is always equals to 0, and so pressure becomes 0, power becomes 0. Okay, so look friends, here what I am saying, as this is the force and this is the direction of velocity, both are perpendicular to each other, so they have 90 angle, and so cos 90 is equals to 0. So friends, this limited to what, that I am say about the uniform circular motion. These are very noteworthy points about the uniform circular motion. Okay, and in case of this uniform circular motion, all these points if you remember, okay, so you never worried about the examples or MCQs related to the your NET, JEE, etc., etc., as well as board exams also. Okay, so friends, next point, that is your non-uniform circular motion. Okay, and now as you observe here, it's a very simple distinguishing. Okay, in case of uniform circular motion, you say speed is remains constant, that is a linear speed. Okay, here the speed is also variable, means how we can define the non-uniform circular motion. So the non-uniform circular motion is defined as the motion of the particle along the circumference of circle, okay, in which the speed is not remains constant or with varying speed. So magnitude, as the speed is not constant, so magnitude of velocity is also not remains constant, because magnitude of velocity means what, that is a speed. Next, the velocity is also not remains constant. Velocity, that is a linear velocity of the particle. Okay, look here, I am talking here about the magnitude as well as direction. Here I am talking about only magnitude. This is the difference. Okay, in case of here, kinetic energy is also remains constant. Sorry, in case of uniform circular motion, kinetic energy is remains constant, but in case of non-uniform circular motion is not remains constant. Okay, what about the angular velocity? The angular velocity in case of a non-uniform circular motion is also not remains constant. Okay, so listen friends, what I am saying again, all the parameters in case of non-uniform circular motion mostly are are constant in case of uniform circular motion, but in case of non-uniform circular motion they are not a constant. Okay, means they are having a certain value, whatever it may be, but non-zero value. Okay, in case of tangential acceleration is also remains constant in case of uniform circular motion, or it remains zero, but in case of non-uniform circular motion it is not equals to zero. Okay, what about the angular acceleration? In the case of angular acceleration, okay, again what we can say, alpha is not equals to 0. Okay, so about the centripetal acceleration. Okay, in case of both, centripetal acceleration is never equals to 0, means having a non-zero value whatever it may be. Okay, in case of net acceleration for non-uniform circular motion is having value under root of AC square plus AT square, because here AC and AT have a certain non-zero values, they are not equals to 0, and so the net value of acceleration is also not equals to 0, while in case of we write directly A net is equals to, or net value of acceleration is equals to centripetal acceleration, because there is tangential acceleration is 0 in case of uniform circular motion, but in case here the tangential acceleration is also having certain value, and so we write the formula for net acceleration as a under root of s square plus at square. Okay, so work done by the force here, in case of uniform circular motion we studied there, the work done by the force is always equals to 0. Okay, we consider the tangential force in case of non-uniform circular motion. Okay, means here we consider this tangential force. Okay, and according to this tangential force, or according to this one, okay, again tangential force as well as displacement of particle both are along the same direction, means they have an angle 0 in between them, and so work done is given by Ft into S. Okay, same thing for the formula for power. Okay, in case of formula for power, that is a work divided by time. In case of as a work divided by time, what we can say, okay, the uh, work having value Ft dot S, okay, divided by time. So again displacement by time is your velocity, and so the product of both, because here the force, that is the tangential force, and the velocity are along the same direction. Okay, here tangential force and the velocity are along the same direction, and so what we can say, the scalar product becomes Ft into V. So in this manner, this is the distinguishing points between the uniform circular motion and non-uniform circular motion. So friends, remember them carefully. Okay, if you have a doubt, you can make a comment in the comment box. Then again, let me start with the point, that is a remember noteworthy point here. In a non-uniform circular motion, okay, always remember that as V, okay, increases, first I am talking about the angular velocity. Okay, so here everyone know that according to the right hand rule, the direction of omega is in upward direction or in a downward direction, that is a perpendicular to the plane of rotation. Okay, so what I'm saying, as omega increases means as you switch on the fan, what happens, your angular velocity of the fan is going to be increased. Fan will starts to rotate fastly. Okay, so angular velocity increases. So at that time, the alpha means angular acceleration is in the same direction to that of the omega. Okay, but as you stop or as you going to decrease the omega, means as you rotate stop the rotations of fan, means as you switch off the fan, so the omega is directed, okay, means it should be going to be decreased, direction remains the same. Okay, but in that case the direction of alpha is going to be opposite to the omega. Okay, understand what I am saying? So simply I am going to explain, if omega increases, okay, means the direction of rotation of blades increases, omega increases, so alpha is in the same direction to that of the omega. But as omega decreases, okay, the value of omega decreases, the direction of alpha is opposite to that of the omega. Look here, this is not the direction of omega, omega decreases. Okay, I am saying like that, omega decreases, means as you stop to rotate the fan, switch off the fan, so what happens, it comes to the rest, and so omega decreases and alpha is having opposite direction to that of the omega. Same strategy we can apply in between the v as well as tangential acceleration at. Okay, in both cases same is there, as a v increases, as a v increases, so what we can say, the value of tangential acceleration is in the same direction, but when the value of v decreases, so tangential acceleration is opposite to that of the particular value of velocity. Okay, so in this manner, this is about the directions. Okay, so friends, again we have to start with the next point in this chapter, okay, which is acceleration. So it's simply the centripetal or radial acceleration. So everyone know why this acceleration is said to be centripetal or radial. Okay, simply it is directed along the center of the circular path, or it is along the radius, and so it is called as a centripetal or radial acceleration. Okay, next thing, in case of this, why this acceleration is produced, or why we consider this acceleration called centripetal acceleration. Okay, so remember friends, this acceleration is produced due to the variation of direction of velocity. Okay, why it is produced? Because of the variation of direction of velocity, and so it is called centripetal acceleration. Okay, simple. Okay, while performing the circular path, so here we seen this is the velocity, this velocity having both magnitude, that is called speed, as well as direction. The magnitude remains constant everywhere, but the direction of this velocity is undergoing change, and so what we can say, the value of velocity is changes because of what, direction, and so it is called centripetal acceleration. And so what we note here, the magnitude of the velocity, that is the speed, remains constant, but the change in velocity due to what, the change in velocity is due to the direction, and so the acceleration is produced, which is known as the centripetal acceleration. So here we write the formula, okay, that is a centripetal acceleration AC is equals to v square upon r, or r omega square, or you may write v omega. Okay, how these formulas are converted? So simple, r omega square, okay, how it should becomes, so simple, as you substitute the value of v as a r omega, okay, means what, v square, v as a r omega. So in that case what we can say, your becomes r square omega square divided by r, okay, and so again r get cancelled, so what is there, only r multiplied by omega square. Okay, in same way we can substitute the value related to what, in this formula, as you substitute the value of omega as a, using the relation v is equals to r omega, so omega is equals to v by r, and again you get the same one. Okay, now the next one is your tangential acceleration. What about the tangential acceleration? So remember, in case of tangential acceleration, okay, in which the magnitude of velocity is also going to be changed, means what, the speed is also not remains constant. Remember friends, while performing the uniform circular motion, the centripetal is acceleration is always there, centripetal acceleration is always there. Okay, tangential acceleration may or may not be present, it always present in case of non-uniform circular motion. And remember, where what we can say, the magnitude is also variable, but obvious direction is a variable. Okay, and so the acceleration which produced due to the variation of magnitude of velocity, or that is the speed also, is called tangential acceleration, and which have a simple formula like this. So after that, and we already discussed these things, okay, in the previous case, as a tangential acceleration increases, as the tangential velocity increases, so tangential acceleration is the same direction. As the tangential velocity decreases, the tangential acceleration is in the opposite direction to that of the velocity. Okay, and the next formula is your about the net acceleration. Okay, we also discussed this formula, simple formula is there, using the resultant of two vectors, okay, that is the AC and AT, that is centripetal acceleration and tangential acceleration, we get the value of net acceleration here. Then it will give us the direction, that is tan theta, can be given by, as you complete the parallelogram in this case, okay, so that will gives you the value of AC divided by AT, which is the direction, and theta is equals to, from this we can write theta is equals to tan inverse of AC divided by AT. Okay, then this is the somewhat summary like structure for centripetal acceleration as well as tangential acceleration. Okay, you must to remember that what is the centripetal acceleration, that in which there is a change in direction produced, okay, or the velocity changes due to the direction. Then what about the tangential, velocity changes due to the change in magnitude also. Okay, and the formulas are there, okay, everyone know that. So next point that we have to start from this chapter, that is centripetal force. Okay, here we are just going to simplify the centripetal force and centrifugal force. So first point, centripetal force. So what is the centripetal force? The force which is directed towards the center along the radius of a circular path. It's called centripetal force. Means in this case, this is a circular path. This is your this is the circular path, and this is the radius vector. Uh, sorry, this is the arrow indicates the opposite to the radius vector. So the force which is directed along the radius towards the center is called as a centripetal force. This centripetal force having a magnitude, okay, F is equals to mv square upon r, or you may write r omega square multiplied by mass, or v omega multiplied by mass. It's simple, okay. That is what the product of mass into centripetal acceleration, and we studied the formulas related to the centripetal acceleration just, okay. Then in the vector form we will write here force is equals to minus mv square upon r into r cap, okay. Similarly here minus mr omega square. So why this minus sign is there? This minus sign is due to only why, okay, this is the direction of centripetal force and this is the direction of radius vector, okay. So this is the direction of radius vector, that is away from the center. This is the direction of centripetal force. Both are directly opposite, and so why there is a negative sign in the given expressions. Again friends, this centripetal force, okay, as we know that there are some forces this exist in the nature, okay. So first one, that is your real force, and other is called pseudo force, okay. So in case of real forces, we studied the types of the real forces, that is electromagnetic force, okay, gravitational force, etc., etc. But as similar to that, the centripetal force is not the type of force, okay, which is simply the property have a force which is directed towards the center. Means the force which is directed towards the center is called as centripetal force. This is not a special type of force, okay. Then this force is the real force, okay. Centripetal force is always the real force. Means it may be the your electromagnetic force, nuclear force, either gravitational force, again, which is always directed along radius towards the center. And one more necessary point to remember, that is this centripetal force produces the circular motion, okay. Means as a circular motion is produced there, the centripetal force is exist. Without centripetal force, circular motion is not possible, okay. And remember, centripetal force and centripetal acceleration both are always along the same direction, okay friends. So in this manner, this is about your centripetal force. Next is your centrifugal force, okay. So what about the centrifugal force? This force is always directed away from the center of the circle, that is along the direction of radius vector, okay. So friends, this force is the non-real force, which may also called pseudo force or imaginary force. Means it exists in the non-inertial frame of reference, okay. What we can say about this force, it's having a simple example. When we are sitting in a car, and as a car, okay, turns towards the right, then our body will leans towards the left, okay. So who one going to apply the force on you? That is this centrifugal force, okay. Means there is no existence of the particular source of the force or the origin of force. You just experience that force because of, we called it as an imaginary force, okay. Because according to Newton's first law, there is no motion will be present in, if the force is not acting, and so we consider this imaginary force. So second thing, this is your along radius away from center. The force is always along radius but away from the center of the circle. Okay, like this, away from the center of the circle. This force is the results of circular motion. Okay, means if circular motion is produced there, the centrifugal force is produced. Okay, remember this relation as a centrifugal force. Centripetal force produces circular motion, and circular motion produces centripetal force. Centrifugal force. Okay, remember what I am saying. The circular motion is produced due to the centripetal force, and the circular motion results centrifugal force. Okay, next what we can say, before the uniform speed reaches by the body, the centrifugal force is greater than that of the real force. Okay, means we can give the example as you start to rotate the fan. So before it reaches to the uniform speed, the centrifugal force is always greater than that of the all real forces. Okay, but when the uniform speed reaches, means at uniform speed, the centrifugal force and the all real forces are equal. That is called centrifugal force and centripetal force are get balanced to each other. Okay, and that's why we can write this formula. Okay, resultant force is equals to minus r omega square, and so as it comes to the right side, okay, so what happens, we can write this formula like this. Okay, so friends, this is the distinguished or particular characteristics of centrifugal force. Means again we study the two comparative points, centripetal force as well as centrifugal force. Okay, means you can distinguish them using these points also. Okay, so the next important point we have to start in the next session, that is applications of uniform circular motion, which is very important for 2 marks questions. Okay, thank you for watching the video. If you have any doubt, you can make the comments in the comment box.